Welcome to Study Loop.
This is the answer to Chapter 13, problem number 42 from the Smith Organic Chemistry textbook. This problem is asking us to look at 4 reactions and essentially to talk about how we could monitor these reactions by IR. And this is one of the industrial uses of IR to measure when a reaction is complete. And so for A, we are hydrogenating a double bond. So essentially we want to look at what will disappear and what new functional groups will form if and see which of those can be used to distinguish products from reactants. So for A, we'll see the carbon-carbon double bond disappear. So remember that should show at about 1650 wave number, but we won't see anything new form, right? Because the starting material has CsP3 carbon hydrogen bonds, and it has carbon-carbon single bonds, and the product has those same bonds. So we're not going to see anything new form, but we should see the peak at 1650 disappear. For B, similarly, we're going to see the OH bond at 3200 to 3600 wave number disappear. And then this time, there's a distinguishable new functional group forming. And so we'll see the carbon-oxygen double bond form at 1700. And depending on how fast this reaction is, we should be able to take 4 IRs over the course of an hour every 15 minutes and watch the OH peak get smaller as the C double bond O peak gets bigger. And then so for C, again, we're going to see the carbon-carbon double bond disappear. So 1650 goes away. And we'll see the carbon-oxygen double bond appear as this reaction progresses. So for D, again, so we said just carbon-oxygen bonds are not going to show by IR. So we have an oxygen-hydrogen bond in the starting material, so 3200 to 3600. We'll see that go away, but we won't see any new bonds form for D. But again, we should be able to tell when the reaction is complete when this peak at 3200 to 3600 is completely gone. And so again, this is one of the common uses of IR in industry, and so this is a good problem. And that's the answer to Chapter 13, problem number